Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class I will teach you the equilibrium. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IIT exam and NEET exam confidently with a good rank. Now let's start about the class. What is equilibrium of a body? Student generally knows that if a body is at rest, then it is in equilibrium. But what is the actual definition of equilibrium? Now, if a body is rest, we know all that it is in equilibrium. But if the body moves with uniform velocity, then the body has also an equilibrium. If the body moves with constant velocity, uniform velocity, then this body is also in equilibrium. So what is the condition of equilibrium? What is the condition of equilibrium? Condition of equilibrium is that condition of equilibrium. What is the condition? Main condition of equilibrium is that the body has no acceleration. Now we know the linear acceleration, that is rate of change of velocity. This is linear acceleration, we call tangential acceleration. And also a body has an angular acceleration, that is if a body rotates in a circular path with constant velocity, then the body has an angular acceleration. So two type of acceleration is present. One is tangential acceleration and another is angular acceleration. So if a body has an equilibrium, then it has no type of acceleration, that is no tangential acceleration and no angular acceleration. So main condition is that tangential and angular acceleration of body is zero. So body has no tangential and angular, that is the body has no type of acceleration. So for no tangential or linear acceleration, we must have all the forces, that is summation of fx0, that is if a body moves in a plane and two coordinate axis, we know in a plane two coordinate axis is required to specify the position of a body, then the condition for tangential or linear acceleration is that summation of fx equal to 0 and summation of fy equal to 0. So this is the main condition for tangential or linear acceleration is 0, fx summation of fx 0 or summation of fy 0. Now what is the condition of angular acceleration? So if a body has torque or moment of force, then the body has angular acceleration. Now to describe the angular acceleration, we know one important term, that is called moment of a force or torque. Moment of a force or torque. What is moment of a force? Moment of a force or magnitude of moment of a force is torque. This is called tau. Okay, this is called tau. What we read as this is tau. Tau equal to, actually tau is a vector quantity, equal to r cross f. This is the actual definition, r cross f. Now what is r and what is f? So if a body, suppose a body, this is a body and it is hinged at that point. Suppose this is a point A, it is hinged at that point. Now a force act to the point B. This is a force. Now if the body is fixed at that point, that is the body can rotate about the point A, then moment of force F, F about point A equal to r cross F. So what is r? R is this is fixed point, that is the body can rotate about the point A. If the body is held by this, then this body can rotate in this way. So what is r? R is the, suppose force is act to the point F. Now r is, what is r? R is this is r. this is r vector and this is a vector. So if the angle between r vector and a vector is theta, so this is the moment of force is a vector quantity and denoted by r cross f. Now what is r cross f? Actually r f into sin theta. From cross product we know. So this is the magnitude of the magnitude of torque equal to rf sin theta. Now if we draw a perpendicular from this, if we draw a perpendicular, this is actually line of action of force. Along this line force is act. Now if we draw a perpendicular from this point to the line of action of force, this is d. Now if this angle is theta, then this angle is theta, so this is equal to f into what is d? D equal to sin theta. From this angle sin theta equal to d by r, so d equal to r sin theta, that is f into r sin theta. If we put d, so torque equal to force into perpendicular distance of line of action of force, perpendicular distance of line of action of force from the point, from the point A, that is if the force is act in this along this line the force act. Now if we draw a perpendicular from this point to this line of action of force, then this is called d. So force, product of force into perpendicular distance, f into d, equal to moment of the force. The moment of force depends on two quantity, the magnitude of force and also perpendicular distance. So suppose this is a door. The door is hinged at this position. The door can rotate about the axis. This is called axis of rotation. Now if a force is applied at the end of the door, that is at here, then we can easily turn or rotate the door. Now if same force act in the middle position, then rotation will not very much, and if the force act through the line of action of force, then no rotation take place, no turning of the door. So that is rotation or turning effect depends upon the force and the distance of the force from this axis of line. Force and perpendicular distance on two factor, force and perpendicular, so both two factor determine the turning effect of a body, that is force into perpendicular distance. Now here distance is short, so turning will not very much. Now if the force is act through the line of action, here if you apply larger force at this point, then no rotation take place, because the distance here is zero. That is force is very much large force, but distance is zero, so torque is zero. If torque is zero, then the body cannot rotate. So this is the moment of force. Now moment of force has a direction. Suppose this is a body and the body is hinged at that point. If a force act in this direction through this point, then if the body is hinged at that point and the body can rotate in this way, that is anti-clockwise direction, then we can take moment is positive. So this is positive moment. Okay, this is positive, that is anti-clockwise rotation is positive moment. And if the force is applied in this direction and body is at that point, then the body can rotate in this way. So clockwise direction is called negative moment. Clockwise rotation, for clockwise rotation we take negative moment. Okay, positive torque or moment, negative torque. Anti-clockwise rotation is positive torque and clockwise rotation is negative torque. So torque has a vector quantity, torque equal to r cross f, as cross product is vector quantity, so torque has a vector quantity. And what is the direction of torque? This is determined the right hand thumb rule of cross product r cross f, that is if the r is present, r is along this direction, if r is along this direction, R is along this direction and F is along this direction, then R cross F means that is normal to the plane at which body rotates. If a body rotates in a plane, then the direction of torque is normal to the plane, determined by the cross product of the vector, okay. So moment or torque, moment of a force or torque is a vector quantity. Clockwise direction, clockwise rotation is we take positive, and anti-clockwise rotation we take positive, and clockwise rotation we take negative torque. Now what is type of equilibrium? Equilibrium has three types: stable, unstable, and neutral. Suppose is conical flask, consider a conical flask. If this is a conical flask, suppose, and if unstable, we draw neutral. This body has an stable equilibrium, this is unstable, and this is neutral. What is the definition of stable equilibrium? Now, if a body is little tilt, that is, if a body is little tilt, then the body can regain its original position. If a body little tilt and then release, then body regain its original position, that is, the body come back to its original position. This is stable equilibrium. And unstable equilibrium, what? If a body is little tilt, then the body cannot regain its original position, that is, the body falls. So this is unstable. If the body is little tilt or slightly disturbed, then the body falls to the ground. So this is unstable equilibrium. And neutral equilibrium, what? Now, if the body is very much disturbed or tilt, then the shape of the body or position of the body remain unchanged, that is, the shape of the body remains same as its initial. So this is neutral equilibrium. Now condition of equilibrium, stable, unstable, neutral, we will study at the chapter of work per energy more in details. So now is one summation of all force equal to 0. Summation of force, as we know, force equal to Fxi plus Fyj. That is, individually we can get summation of Fx0 and summation of Fy0. And second condition is torque, summation of torque equal to 0. So body has no type of torque, This is if torque is 0, then the body has no angular acceleration, and if Fx Fy 0, then the body has no tangential or linear acceleration. So these are the condition of equilibrium. Suppose this is a body of mass m, and two string. This angle is θ1 and this angle is θ2. So this body, the body has supported by two strings which is attached to the two vertical wall. If the body is in equilibrium, find the tension T1, T2. Find the tension T1 and T2. Vertical line. Now if this θ1, this is θ1, and if this θ2, this is θ2, so T1 is act in this direction. So T1 has two components, T1 cos θ1, and this is along T1 sin θ1, and T2, which is this in this direction, T2, this is T2. So this has two T2 cos θ2, and this is T2 sin θ2. And the weight of the body acts vertical downward. So now if we apply the condition of equilibrium, then summation of Fx0, which means that if we take x-axis along this and y-axis along this, then x-axis force along the x-axis is T2 sin theta minus T1 sin θ1, which is equal to 0. So this is one condition. So we get T2 sin θ1. Now if we apply summation of fy equal to 0, which means t1 cos theta 1 plus t2 cos theta 2 equal to mg. So put t2 equal to t1 sin theta 1 by sin theta 2 into cos theta 2 equal to mg. So t1 equal to mg sin theta 2 divided by sin theta 2 cos theta 1 plus sin theta 1 cos theta 2. So that is sin theta 1 plus theta 2. Sin a cos b plus cos a sin b, cos a sin b, sin a cos b plus cos a sin b, that is sin a plus b, sin theta 2 is this. So this is the answer, t1. And if we put t1 in the at here, then we get t2. So t2 equal to t1 sin theta 1, that is mg sin theta 1 sin theta 2 by sin theta 1 plus theta 2. T2 equal to t1 sin theta 1 by sin theta 2. So by sin theta 2, now cancel sin theta 2, we get mg sin theta 1 this. So t1 equal to mg sin theta 2. So this result you can remember. For MCQ, you just put theta 1 theta 2, you get the answer t1 t2. You get the answer t1 t2. Just put theta 1 theta 2 at here, you get the result t1 t2. Or if you cannot remember the result, then so if you cannot remember this, then you can write the equation of equilibrium. Suppose this is a ground, this is a vertical wall, and a ladder is ladder of mass or weight, ladder of weight w is held against the vertical wall. This is ground and this is vertical wall. A ladder is supported against a wall and ground. So if the ladder is in equilibrium, find, if the ladder is in equilibrium, find the normal reaction between Na. Suppose this point is A, this point is B. Find normal reaction at A and B, and also friction force at A. The ground, this end can slide along this ground, so a friction must required to stop the motion of the end A. Okay, now if the ladder is in equilibrium, then find find reaction at A, B, and the friction force at A. So this is the question. So if we apply the condition of equilibrium, then what we draw the picture at here. Now if we draw the picture at here, at A, normal reaction is always act normally. Normal reaction always acts normally to the plane. Now this is direction of Na, then the normal to the plane, normal to the wall, that is NB is the direction, and weight of the length of the ladder is also given L, and the weight of the ladder acts through the center of gravity along this direction, vertically downward, and the angle theta is given, L is given. You have to determine the Na, NB, and friction force. Now if friction force act along this direction, FD, FR, friction force, FR, which is equal to, in friction chapter we study that a constant of coefficient of friction into Na, this is friction force. So mu is not required here. So we can find friction force Na, Nb from the condition of equilibrium. What is the condition of equilibrium? Nb W. What is the condition of equilibrium? Summation of Fx equal to 0. So summation of Fx, here only one force. Here the two force act along the x-axis. X-axis means this is, if this is x, then this is minus x. So x-axis means this or this, along this. Summation of all the force along x-axis is equal to 0. So Nb act in this direction and friction force in this direction, minus Fr equal to 0. From Fr equal to NB. So this is the one condition, and if summation of from summation of Fi equal to 0, we get Na minus W equal to 0. So that is Na equal to W. Now friction force NB. Now what is the condition of, now we have to apply another condition, that is summation of torque equal to 0. Now taking torque, we have to consider one point. Which point we consider? We have to consider one point, this point or this point. Now which point we consider? Consider that point which through which the point through which maximum force acts. You consider that point. So here Na, if two force act through the point A, and here only NB acts through the point B, so we consider the point A. So if we have to take that point and taking the moment of all force about that point, taking moment of all the forces about point A, we have taking moment of all forces about point A. What we consider? Moment of the force Na is 0 because Na into 0. Here perpendicular distance is 0 because Na acts through the point A. So perpendicular distance is 0. Now moment of the force NB into d1. Now if we hold the ladder at that point and force is applied in this direction, then the ladder rotate in clockwise direction. So it is taken as negative. And now remain force is weight W into perpendicular distance is d2. Now what is the sign of this moment? The sign of the moment is, if we hold the ladder at the point A and weight act in the direction, so the ladder, suppose this vertical rod is not supported, so if we hold the ladder at that point A and weight is act in this direction, then the ladder rotate in this direction, that is anti-clockwise. So we take this is positive, so no other force is present here, so this summation of the moment is 0. Now what is NB? So NB equal to W d2 by d1. Now we calculate d2 and d1 in terms of L and theta. What is d2? d2 will be L by 2 into cos theta, because this is L by 2, total length is L equal to length of the ladder and weight act at the middle position. So this will be L by 2, length of ladder L by 2, and from this triangle we get d2 equal to L by 2 cos theta. From this triangle we get cos theta equal to base by hypotenuse. So d2 equal to L by 2 into cos theta. Now what is d1? From this d1 means this and this, so this also d1. If we consider this triangle, then from this triangle what is the sin theta? Sin theta equal to perpendicular d1 by hypotenuse L. So d1 equal to L sin theta. Now put d1 equal to L sin theta here, so we get W cot theta by 2. So this is the reaction NB, and reaction we get Na, and also this is friction force. So friction force equal to friction force equal to NB, which is equal to W cot theta by 2. So this is the answer. Now one important point is that if what is concurrent forces? If the different forces act to the same point, that is line of action of all the forces meet at a common point, then F2, F1, F4, suppose F5, all forces are concurrent forces. These forces are concurrent forces because all the forces passing through a common point. And if F1, F2, but F3 act in this direction, so this passing through a point, this passing through the point, but it all the forces has no common point, all the forces has no common point, so these three forces are not concurrent. Or if all the forces passing through a common point, these are concurrent forces. But if two forces passing through a common point, but all the other forces that is it has all the forces has no common point, then they are non-concurrent forces. Now for concurrent forces, total torque will be 0. For concurrent forces, torque equal to 0, because if we take a point A and take a point and taking moment of all the forces about point A, then no perpendicular distance is present. This perpendicular distance of all the forces about the point A is 0, so torque is 0. For three concurrent forces, we can solve the numerical by applying the condition of equilibrium. Now we can solve the three concurrent forces by Lamy's theorem. So what is Lamy's theorem? Suppose this is a body and three forces act this in this way, F1, F2, F3, and the angle of this angle, if this angle is theta 1, this angle is theta 2, and this angle is theta 3, and this angle is theta 3. So Lamy's theorem is that F1 by sin theta 1 equal to F2 by sin theta 2 equal to F3 by sin theta 3. So that is F1 by its opposite angle sin theta, F2 by its opposite angle, F3 by its opposite angle. So these angles are opposite angle of the force, applied. This statement is Lamy's theorem. Now how to use this theorem for solving three concurrent forces. So if this angle is 60 degree, this is 30 degree. Suppose this is 2 vertical wall is present and a block of mass, suppose 30 kg, a block of 30 kg is supported by the two string. Now all the tension T1, T2 and the weight, these three forces must passes through a common point. If the body is in equilibrium, the three forces must be concurrent forces. So three concurrent forces, for three concurrent forces we can apply the Lamy's theorem. So what is the angle? Just we have to find the angle. What is this angle? If suppose this is a vertical line, now if this is 60, then this is 60 degree, and if 30, then this is 30 degree. Now 60 degree, and the weight of the body act in this direction 30 g. Now T2 this direction, T1 in this direction 30 g. Here three force is present here. Now if we apply this, so T1 by sine opposite angle, T1, that is this force. What is the opposite angle? Now we have to find out the three angles. So if this is F1, this is F2, and this is F3. Now what is theta 1? Theta 1 is the angle of this is 60. So this angle is what? 180 minus 60, 120 degree, because total angle is 180. 180 minus 60 equal to this angle. Theta 2 is equal to 30. 180 minus 30, 150 degree is theta 2, and theta 3, that is this angle is theta 3, which is equal to 60 plus 30, 90 degree. So we get theta 1, theta 2 and theta 3. So apply here T1 by sine T1 by sine 120 equal to T2 by sine 150 equal to T3, that is weight of the body 30g by sine 90. So from this we get T1 and T2. T1 equal to 30 into G 10 into sine 120 sine 180 minus 60, sine 120 equal to sine 180 minus 60, that is sine 60 degree root 3 by 2. So this is T1, and from this equal to this, from this we get T2. T2 equal to sine 180 minus 30 degree, 180 minus 30 sine 30 equal to half, so half into 30 into 10, that is 150 Newton. So this is T1 and T2. We get by Lamy's theorem we can find the tension T1 and T2 from the one end of it. Suppose this string this is a string, this string is length of the string is 0.5 meter string fixed, and other end is first a small object of weight 8 Newton. Suppose this is a small weight of this object is 8 Newton. The object is pulled aside by horizontal force. The object is pulled by horizontal force F until it is 0.3 meter from the vertical throw A. That is, this distance is 0.3 meter. Find the magnitude of the tension T in the string and force F and force. Here T equal to what? F equal to what? This is the question. A string of length 0.5 meter is supported from a vertical wall, and another end of the string is attached with a body of weight 8 Newton, and a horizontal force F is act on the body, so that the string makes this end is at 0.3 meter from the vertical wall. So now what is the force F and T? Here we can apply the Lamy's theorem. Now we can apply Lamy's theorem for this problem. What is the angle? If this angle is theta, this is theta, so this is 90 minus, so this angle, what is this angle? This angle will be 180 minus theta, 180 minus theta. Now this is 90 degree, this is 90 degree, so F and 8 Newton is angle 90 degree. And what is this angle? This angle will be this is 90 plus theta, 90 plus theta. If this angle is theta, then this angle is 90 plus theta. So we can apply Lamy's theorem. We can apply Lamy's theorem. F divided by total angle, this sine 90 plus theta equal to T by what is this angle? This angle will be T sine 90 equal to 8 Newton divided by 8 divided by total angle is 180 minus theta. 8 this opposite angle is 180 minus theta, sine 180 minus theta. So F equal to 8 into sine 90 plus theta is cos theta divided by sine 180 minus theta equal to sine theta, and T equal to 8 by sine theta. Now from this we get sin theta equal to first take cos theta equal to base by hypotenuse 0.3 by 0.5 0.3 by 0.5 equal to 3 by 5 cos theta equal to 3 by 5, so sin theta equal to 1 minus cos square theta, that is 4 by 5. So we get 10 Newton, and this is cos theta equal to 3 by 5, sin theta equal to 4 by 5, 3 by 4, that is 6 Newton. So this way we get F and T. Student, this is the end of the class today. To get such type of video and to continue the theory, subscribe my channel. Okay, thank you.